So before we get into talking about projectile motion, first thing I want to do is talk about free fall. So for a free falling object, say if we have our objects starting off right here, what we're going to see is that maybe after 1 second, the object will have a velocity going downwards like this, and this is the velocity after 1 second versus after 2 seconds. Maybe it'll look like this. So this is the velocity after 2 seconds, and after 3 seconds, maybe the velocity will look like this. And what we're seeing here is there's a change of velocity. And what's another word for change in velocity? Acceleration, right? So what's the reason why this object is accelerating? So the ball will come down like this, and this over here, and after 3 seconds, it'll be down here. So what's the reason why an object will change its velocity or accelerate during free fall? Well, because it's being subjected to the force due to gravity. And so it's that force right there that will cause it to have the change in velocity, give the ball the change in velocity in the y direction. So for projectile motion, projectile motion means that you're going to have velocities in both the x and y direction. So if we have this ball and we give it an initial velocity in the x direction, the ball's going to go in this trajectory, and maybe after 1 second, the ball will end up in this position over here. So it's still going to be moving in the x and y direction. It will still have this velocity in the x direction, and it'll have this velocity going downwards in the y direction. And maybe after another second, the trajectory of the ball will make it end up over here, and it will still have a velocity in the x direction and a velocity in the y direction. And maybe another second later, the ball will end up down over here in this position. And it will continue to follow this parabolic trajectory. And once again, it will have this velocity in the x direction looking like this, and the velocity in the y direction looking like this. So that's the parabolic trajectory of the ball. And let me ask you this. What do you notice about the velocities in the x direction? You might have noticed that they're the same throughout the entire trajectory. And that's true. And why is that true? In the y direction, we know that there's the force due to gravity acting on the object. Are there any forces acting on the object in the x direction? Well, no. Well, that's not entirely true. Maybe if we're just completely neglecting air resistance, but if we're in this environment, if in our system there's no air resistance, this is the trajectory that we'll see, and we will see that the velocity in the x direction will remain the same. So once again, the horizontal component of the velocity does not change, whereas the vertical component of velocity where the vertical component velocity does change. And those are key components. Those are key ideas in projectile motion. This right here, the horizontal component of the velocity does not change, and the vertical component of velocity does change. So the horizontal and vertical velocities are independent of each other. They do not affect each other at all. So this is one example of projectile motion. What about this over here? So say if we are given an initial velocity on a certain angle. This looks like maybe a 60-degree angle or so. So either way, we're going to have a vertical component of this velocity. And say if after 1 second, the object is over here. Well, there's going to be a vertical component of this velocity. and a horizontal component in the velocity. And maybe after another second, the object going through this parabolic motion will be ending up over here, where once again we do have this vertical component of the velocity and the horizontal component. After another second, maybe the object will stay up, be over here, where once again we do have the vertical component and the horizontal component. And if I'm drawing this correctly, the horizontal components of the velocity will not be changing. And maybe after another second, it'll end up over here where we have the horizontal component going like this, and the vertical component of the velocity going downwards like this. And after another second, it should be like this, where we have the horizontal component of the velocity and the vertical component. After another second, it'll be like this, where once again, we'll have the horizontal and the vertical. So once again, you're still seeing that in this parabolic path, the parabolic trajectory, the x components will remain the same. The horizontal components of the velocity do not change. All right, and so I'm just going through this right now because these concepts, they do matter when we'll be solving these problems. And I'm just going to go through this last one over here. Obviously, we're given a certain height, and the difference here is that we're not going to be ending up over here on the same height, but we're actually just going to be dropping down over here. So let's take away those, and I'll just go through this one more time. So maybe, once again, we're going to be having the initial velocity of the ball going up on, it looks like a 45-degree angle or so, where maybe after 1 second, the object will end up over here, and we'll see that we have a vertical component of the velocity and the horizontal component. Maybe after another second, it'll end up over here. I know that these are pretty close together, but whatever. Doesn't really matter. Where we have the vertical component and the horizontal. I'm really just trying to drive home here that these do not change. Okay. Bam, just like this. I'm really starting to squeeze in here. Sorry about this. I understand that this is kind of bunched up and everything, but the concept being that the horizontal components do not change. And after another second, we'll be over here. And we're just dropping down like this. And maybe after another second, we'll be over here, where we have our horizontal component. I'm sorry about this getting bunched up. I thought I planned this out pretty nicely, but I guess that's one thing that I didn't account for, seeing how bunched up this will be. But I think that the concept is pretty clear right now, what I want to drive home. And that is the whole reason for this lecture right here. And once again, what's the whole reason why the y component is changing? It's because it's being subjected by a force, the force due to gravity. And the whole reason why the horizontal component doesn't change is because there's no forces that are acting on the object in the x direction. And that's pretty much the concept that I want to get across for this lecture right here. And please let me know in the comment section if you have any questions.